Welcome back, folks. Today we are looking at the Luckfox Pico Max because it is fucking awesome. I've got heaps of these in stock now. I bought 100 of them because I like them that much and I'm going to use a lot of them. So I thought I'd show you what they can do and why I'm so excited about them. And yes, I'm still swearing because PCBWay said that it was okay to. More on that in a minute though. So, this is similar to the Pico and the Pico Mini, which I've shown you before. However, this has the RV1106 instead of the 1103. So this is 1.2 gigahertz 32-bit ARM SoC, and it's got 0.5 tera operations NPU. It's got H.264 and 265 hardware encoding. It's got dual SDIO for Wi-Fi and SD, so you can add Wi-Fi onto this if you wanted to. Dual lane MIPI CSI, as you can see, there's that little connector there. And it has apparently 760 milliwatts consumption when the 5 megapixel camera is plugged in. So we're going to test this out. Now, I'm also going to give this one away, and I might as well give the camera away with it. This is one of the new stock that I just opened. I've flashed it with the latest image. It does come with the image from the factory, which is really handy. You can literally plug these in and get going. But I just wanted to make sure that I'm using essentially the latest to show you what the latest does. First of all, though, I did want to thank PCBWay. They said I can swear, which is awesome. I'm doing that because YouTube shows way too many adverts, and apparently saying a few words in the first 7 seconds upsets YouTube, and they don't show as many ads or upsets the advertisers. I'm very okay with that. PCBWay, though, are continuing to sponsor just my projects, not even just this channel, but things like helping me out with designing these awesome PCB rulers. This is the matte black one. Let's get some focus up a bit closer for you. These are limited edition. I've got them in my shop now. They're in black and purple, 15 and 30 centimeter, and I reckon they look really bloody good. So, I've still got the free ones I'm giving away, but that's the quality of PCBWay's service, basically. You can see it's immaculate. Now, they're also going to be helping me make a Luckfox product. They aren't aware of it yet, but I'm going to be making an add-on for the Luckfox as a project with PCBWay, and they'll be supporting that as well. So you should go check them out. There's a link below for $5 off your first order if you use that. Otherwise, check out their store, their assembly services, everything they offer is pretty bloody awesome. Now, back to the product. You can buy these on my shop. As I said, link below. I've got a pile of accessories for them, and there's a lot that you can do with them. So they have 100 megabit Ethernet, as you can see there. You can add Wi-Fi onto them. They have UART on pins 1, 2, and 3, so really easy. You can actually see there if I pull the focus in. There. TX, RX, and ground. So really easy to grab UART on there. They've got Samba or CIFS enabled and ADB enabled, and RNDIS enabled by default. So you can pretty much plug them in and access them straight away. I've shown you that with the previous two models. And then they also have this RTC battery connector. So if you're going to be using this for any application where it's going to lose power frequently, that would definitely be worth looking at. The RTC batteries are really cheap, and it means you're always going to have a consistent time source. So these are a really impressive little product. Now, they do have some downsides, at least in my opinion. So the Rockchip SDK for these MCUs or SoCs only has the Linux kernel version 5.10. Now that's okay, but I really would want a newer one, especially if you're going to try to use Docker or something like that. You'll run into some issues. The SD card, when you insert it into this slot here, actually sticks out over the MCU, so you can't put a heatsink on the MCU if you're using the SD card. I think that's a bit of a design flaw that could be fixed by moving to the bottom over the SPI flash, maybe. This 20-pin connector for the camera ribbon is non-standard, and the pins are in a really messed up order. So it only supports their cameras, which I think is kind of really terrible. I've looked at making an adapter board, and I probably will. Everything's either got 15 or 16 or 21/22 pin FPCs, and the pins are in the same order, just spaced differently. This isn't. So I think that's a really big downside. I would also like a mounting hole or like notches in the sides so it can clip in firmly into something. But again, that's just me and isn't strictly necessary. And then lastly, by default, it uses Micro C, or the Micro C library, UClibc. That makes a few things hard as well. You can work around that with the SDK though. You can compile it against different libc libraries. But by default, it uses that, which also causes some complexity. So most of them are really easily overcomable. The camera connectors are really one big downside for me, but so be it. The camera is actually pretty bloody good. Say 5 megapixel camera, 3 megapixel camera, and I believe there is a 5 megapixel option, and it sure as hell does the job. So we'll show you a bit of that as well. Alright, so first things first, let's have a look at how much power this thing draws. We don't have an SD card in, we don't have the camera connected. I'm trying to see if it's sitting there idle, what's it doing? What's it chewing up? How long is your battery going to last? Alright, so you can see the little heartbeat LEDs going there. It's booting up. That'll turn into just a constant ticker or heartbeat once it's booted, which is actually generally pretty quick. There we go. Oh, it's doing something. There we go. So that's drawing 52 milliamps. That's insane. 52 milliamps, 53 milliamps is very, very low power consumption, which is quite excellent. Let's connect this camera up now. Cool trick for these boxes that are annoying to open is just shove a ruler in them, although sometimes you tear it. There we go. Don't forget to take this little cap off. Believe it or not, people do forget. And when you're connecting this, note there's a blue side and a side with a metal pin. Some people do also get this wrong. So you just slide that up. Let's get a little bit more focus in here. And you want the metal pins facing towards the MCU. And then you push that connector back down. So now we're gonna sit that bloody unwieldy ribbons. There we go. There, and we'll plug this back in and see what sort of power consumption we get. Now the way these work, when the camera's connected and it boots up, there's a process running on the NPU using IPC to communicate with the main operating system, and it's called RKNN, or RKIPC communication, but RKNN. And you'll see in one of the directories on the system, there is a folder with all the tools to start and stop and change this. But by default, what this is going to do with the image out of the box, detect the camera, start the process, and stream it on the network. So you can either access the network by plugging it in, or you can access it using the RNDIS interface, which is enabled by default. Now, the downside of RNDIS is it's not really supported on Mac. There are some workarounds, but it's something that's even been removed from the modern Linux kernel because of its insecurities, because it's a Microsoft-oriented feature, and because there's so many other options these days. So this is running now. The heartbeat's going to keep ticking because it is doing more, essentially broadcasting this. But you can see it's drawing kind of 165 to 230 milliamps, which is pretty awesome. Let's plug the network in now and see if that changes much. Alrighty, I've got a network cable plugged in now, and we can see it's jumped a little bit. So it's maybe doing like 185 up to 245 now. That makes sense. It is to send data down that cable. It is transmitting electricity, so you'd expect it to show up a little bit more. There'll be a little bit more processing going on. It would have had to get a DHCP address. Now, there's a few little things to be aware of with these, and one of them is the MAC address changes on every boot. I'll show you how to change that though. You can use something like Angry IP Scanner to find it, or if you go into your router's interface, you'll be able to see the DHCP leases. That's what I do. However you want to find it is up to you. It is a static IP on the RNDIS interface, but yeah, DHCP on Eth0, and there's different methods to change it for each image. So we'll have a quick look at that now, and we'll play the live stream. Let's jump over to the computer. Alright, so on the computer now, I've quickly looked up the IP address, and it's good to be aware as well that there's two different usernames depending on what image. So the default SPI flash build root, or BusyBox if you make your own, but build root based one uses root as you'd expect. So we're going to SSH root at 10.12.20. Whatever it was, 41. Yes, we want to accept the key, and the default password for both instances is just LuckFox. So we can see we're there. You can see the RAM. Now it is 256 meg on this, but it does reserve about 64 meg for the camera interface. So anything you're doing with the NPU is going to need some RAM to process those images. It reserves 64 meg for up to a 5 megapixel camera. You can adjust that in the image when you build it though, and the docs show you how to do that. If we have a look, I can't believe it's got HTOP out the box, you can see RKIPC is sitting there running. That's communicating between essentially the NPU and this Cortex core. But you can see, wow, the load's actually pretty high. That's going to be due to running that camera. But it's otherwise looking really good. Now, if we pull up VLC, we can essentially just go VLC RTSP 10.12.20.41 live 0. And if I pull this across to this screen, there we go. It's upside down a bit because my camera's on the wonk. It's got a focal length there of, let's just move that. There is a default 1 millisecond lag with VLC, but the focal length is fixed, and it's about 25-30 centimeters to essentially infinity. As you can see, this 3 megapixel camera is also pretty bloody good. So I've got to give that some credit. But that's streaming real time at boot. So you don't have to do anything. You can plug this thing in, get its IP address and start watching it. You essentially have an IP camera that you could connect up to Shinobi or Frigate out of the box. All that's missing is PoE, and I'm going to fix that. Not in this video, but if you put 2 and 2 together, you might figure out how I'm going to fix that. I love PoE. Now, the cool thing is that it actually comes with a lot of documentation. They really clearly go through how to use all these different interfaces. So if you have a look at the doco here, they give you the Arcanien interface explanation. So they explain what the toolkit is, what models they use, why they use them, everything like that. I think it's extremely well put together. They then go into how you would tie essentially RTSP, the camera, Arcanien all together. And if you jump down to the very end here, they've got a few examples. The awesome bloke LuckFox29 put together this repo. So we can go and grab, say, RTSP YOLO V5, and it gives you some basic understanding of what it's doing. You do need the SDK, so that's, if you search GitHub, LuckFox Tech, they've got a repo with just the LuckFox Pico SDK, and some pretty good instructions. It's pretty straightforward. I've used it a fair bit, and it's very dynamic. I'm using this to make my own repo, to make my own images. I am customizing them a bit. It's not finished yet, so that's still kind of a work in progress. You can see that here. I have noted not done yet, but it's still out there. They haven't updated their repo since then anyway. Now, I did actually grab this one. I thought it'd be really good to show some object recognition streaming over RTSP, and I compiled it and I sent it across, but I've found some endless issues. Some other people have reported it, but essentially it starts and then seg faults, and I haven't really gotten too far. I can see here they're seeing a frame rate of 0, and then it says the device isn't compatible. I'm not entirely sure why, because it does work with the other processors built in. Now, if we have a look at OEM user bin, there is a whole pile of different examples in here, and I've seen similar results with some of them, so there could be an issue with the SDK at the moment. I've tried the one it's shipped with, and I've tried the current one, and yes, I did do the stop command to make sure the RTSP stream had actually stopped before I started it. You can always restart it if you want, like that, and then it's off to the races. I think that's backgrounded. It will, of course, also start automatically when you boot it up. So I'm not too sure what that is, but what we can do now is boot to the SD card and have a look at the RAM there. At the performance there and what the Ubuntu environment's like. Now, this obviously has some great implications as a AI kind of PoE, or not PoE, an AI network camera, an IP camera. There's a few other things that people have suggested, though, that I've thought of. So if you can get a newer Linux kernel on there, you could use it as a Docker host. There is an Alpine Linux port, which we'll have a look at. You could use it as a smart doorbell. You could do a DIY drone, because you've got 26 odd GPIOs on there, which is pretty awesome. There's a lot of different options. As I said, I'm going to give this one away. So leave a comment below with what you would use it for. And whichever comment gets the most upvotes, we'll say in 2 weeks, I'll send this one to you anywhere in the world, free of charge. It is also worth looking at, if you're going to be doing anything like that, the Arcanien Model Zoo that Rockchip put out. So this repo actually goes through the support for the different chipsets, all the different models that they have available, and then the performance of them on a variety of different cores. So they don't have the 1106 on here, they've got the 1109, which will be close-ish, a little bit more powerful, but you can see the YOLO V5 is pretty good. That's going to give you decent performance at intake, maybe 15 FPS on the RV1106. So what I've got now then is this SD card, which I've flashed with the image, and we'll strip this back to defaults. It does also say that to boot to the SD card, you need to erase the SPI flash. I've found that not necessary. I think the newer version, the bootloader might look for SD first before it actually goes to flash. So now if we hit that and then hit that reset button, this will boot up and we'll be able to see some different power consumption there. Alright, so that's consuming about the same amount of power, which makes me think maybe it's not running Ubuntu, but what we'll do is we'll plug it into the network, we'll connect to it, and we'll see what it's doing. Please. Alrighty, so as you can see, it's got another IP address now, and the username I'm using is Pico. So, if this actually logs in, we know we've got what we want, and there we go. So we can see this is Ubuntu 22.04, which is excellent. If we have a look, everything's going to be otherwise much the same. Now, first things first, let's grab this. Oh, it's also worth noting they have minimized it. They've made it as small as possible, but they give you a script that's going to add all those packages back in. I think that's really handy, and I quite like that message of the day too. Very nice work. Now, the IP, the MAC address here is that one, which is different, and that's why we got a new IP address. And what we want to do is go VI etc network interfaces. And I don't think there is going to be one there, no. So we'll just put it straight in here. And we'll go auto ETH0 hardware address. God, I hope that's right. I forget sometimes. iNet DHCP. That should be right. So now, if we give it a quick reboot, alright, do it that way. No. Interactive authentication required. Alright, so it is very, very minimized. Can I do sudo su dash? No. That's interesting. Alright, so there is a little fault in the current SDK. So you'd probably want to modify it or be aware of this before you write the image and change that comp file. So in this case, I don't have any access, I don't think. And the root user doesn't have a password set. So you'd expect that to be fairly problematic. We'll just power cycle it the old school way with this button here. Yep, and that's not responding. So we'll let this boot back up and we'll reconnect. It should have the same MAC address. It should have the same IP address. I made a mistake. I just remembered that. So I would have got the next IP in the range. I'll have to connect to that. And actually, I might have completely broken that Ethernet interface. We'll find out in a second. No? Alright, cool. The reason that it got a new address is because I missed the word ether when I was specifying the type of hardware address that I was going to give it. You can see this is, alright, it's only consuming 73 milliamps, so it's not going to be running the camera model by default like this. Let's go HTOP. Yep, stock standard now. If we go VI etc network interfaces, what we wanted here was that. That's it. That's simple. So we'll save that for next time. So what I'm now going to try is that YOLO V5 test again with a different build that I've compiled against the SDK configured for the Ubuntu image, if that makes any difference. So if we go SCP, LuckFox, Ubuntu, Pico at 10.12.20.42 we're up to. And let's get our home directory. 43 even. LuckFox. That's sent it across. Make it executable and try to run it. I've had that same error a few times and I'm not entirely sure. I think it might be, yeah, I don't know. Something's a bit off there. If you have any ideas, I'd love to experiment a bit more with this, but currently that doesn't work. The Luckfox engineers are actually on holiday at the moment, so I can't even ask them. And I'm short on time, so I don't really want to be spending too much time working on that. You can see that the build route, build out of the box did work to some degree, just without the neural interface stuff. And there are some INI files you can change to add models into that default RKNN configuration. Now, the last thing we want to look at is, actually, second last thing, let's have a quick look at the temperature here and see if it is actually putting out much heat. And then I'm going to try out this Alpine Linux image. So if you have a look here and we go back to the documentation, under quality community sharing, they've got links to how someone made Alpine Linux for this and the image. So I'm going to pull the SD card out. I'm going to flash the SPI flash. Actually, I'll see how big it is. It'll probably be on the SD card. And we'll boot up to Alpine Linux and have a look what that looks like. As far as the thermal properties go, got my Topdon TC01. Okay, it's sitting at about 35 degrees. You can just see the camera in the reflection there. Let's give it a little bit of focus. 38 degrees isn't bad. I'd want to put a heatsink on that because there is a very good chance that it will thermally throttle itself, but that's definitely doable. So now I'm going to flash this with Alpine Linux, which everyone loves. We'll get back to it. Give us a tick. So I'd say to get Alpine Linux working on the RV1106, that it would need to be a fresh image. They left good instructions at least, which you can see in here, translated to English badly using Google Translate. So I might have a play with that today. I'll put the image below if I get it working, or the notes in the description otherwise. But I'd love to know what you want to use this for. Leave the comment for your chance to win one. All suggestions are good, but I think this is an awesome processor. It's 1.2 gigahertz. It's the size of a stick of gum. It's got the 0.5 tera operations NPU built in, so this could do so many things. I think drone is a really good way to go. I'm going to be using them mostly to monitor my plants, so the camera can keep an eye on the plant health. The neural network, when I train it using the instructions, actually, if you have a look here, this is something worth pointing out. If we go back to the AI Rockchip repo, and then you go to Yellow V5, this is the one. Yellow V5 is recommended. It supports a lot of different models, of course, but Yellow V5 is really good. And they give you some information here on why, but this documentation is excellent. So it's got training custom data and tips for best training results. Now, essentially, my idea is these will run off either PoE or solar because they don't require much current. They've got heaps of GPIOs, so these will have temperature sensors, water or moisture sensors, all sorts of things like that hooked up. Camera will watch the plants, and these can automatically report. I'll probably add a LoRa interface or something to them. These can report the plant health for me because I have a huge garden and lots of plants. But what do you want to do with it? That's what I want to know. Thanks again to PCBWay for continuing to support this channel, making awesome products, and helping you guys out by giving you the $5 discount when you first sign up if you want to get started with them. Don't forget to check out my other channel if you're curious. It's all like cookware, recipes, stuff like that. Link to that below as well. Alright folks, it's been a few hours and I've been working on this pretty hectically, but I think I've finally got Alpine Linux working. Looking at this guy's instructions here is pretty good, but I realised some of the issues. First and foremost, he has a static IP set. He wasn't using DHCP. So I've gone through and I've modified this a fair bit now. I've added vim, bash, less, screen, wget, exfat file, sudo, v4l, alpineconf, ffmpeg, htop, and neofetch. Now I know FFmpeg is quite heavy, but these are meant for video processing, so I figure the slightly bigger image is worth it. Now, I've also left the repos. He changed his repository to the Alibaba one. I found them fine, so I've left them as default. I've added the user Pico and added that to the wheel group. I've set the default. Where's he? God, I don't know what name servers he's used. I set name servers to be Google and Cloudflare, enabled DHCP, and tested it all out. So I've just flashed it, and if I connect to it now, Pico and Luckfox, it's working, and you can see I have tagged it as required, and I've also, flogging my own brand. You can buy one here. Now, it doesn't have RKNN, of course. It's not going to be doing any of that neural network. This is just Alpine Linux running on it. And proc CPU info. There's the processor. It's using only 9 meg of RAM, including SSH, which is bloody excellent. HTOP's looking happy. There is not much going on at all. And did I add NeoFetch? Yes, I did. There we go. So that's working excellently. There are some minor issues with this which appear to be part of the SDK. So I've got this image here, which you can come grab. Now, LuckFox Tech GitHub. The issue is specifically around sudo and su. And I don't recall this being an issue previously. Now, I've tried a few things, like modified the build script to change it, but couldn't get it working reliably. So I've raised this issue, and we're hoping they fix it. But this is otherwise Alpine Linux running on the LuckFox Pico Max with all the tools that you're going to want to, have a play around with basically everything that you need to get going. I've also built this for the RV1106 because his build was for the RV1103, so I'm not sure if that would have stopped it booting either. And you could enable that heartbeat light again. He's disabled it. I'm happy with it off for now. So I hope that's something fun for you guys. Enjoy the rest of your afternoon. Thanks for all your support. Catch you next time.